Oh, hello there, and welcome to my channel. Today, I'm going to explain two-dimensional motion with constant acceleration. Come join us to explain this. Teachers, maybe you should give me extra points because I'm recording this by myself, and I'm holding my phone with the stairs, so yeah. Okay, so we go. To get to better know the two-dimensional motion with constant acceleration, we must know what a projectile is. It's a particle that moves near to the Earth's surface only with its weight. This is a projectile. To analyze its behavior in time, we must decompose it in the axes, such as the x-axis and the y-axis shown in these formulas. And once we have the components, we obtain the position and the velocity with these two equations also. I also forgot that sometimes you will need the velocity as a vector, and you'll have to use these equations. So remember that? Okay, so I'm not gonna explain step by step like I did in my past video because it drinks a lot of my time and I want to make this video better. So a ball rolls on a table and falls at the edge of it with an initial velocity of 20 meters per second. If the table is 1.2 meters above the ground, find the time it took to the ball to hit the ground and how far it went from the table. So I make a little ugly sketch down here. So this is the table and this is the ball. It's going downwards, you gotta find the distance in x, remember that, and the time it took to touch the ground. So the initial velocity in x will be 20 meters per second, and the initial velocity in y will be 0. So we're going to use this formula, and as we know the initial velocity of y and the gravity, we're just going to replace that into the formula. So it will be minus 1.2 because the distance is going downwards, is equal to 0 times time, which will be equal to 0 even though we don't know time, plus 0.5 times the gravity, negative because it is going downwards, not going up or something, to times square. So it will be minus 1.2 will be equal to minus 4.9 times square. So this one is multiplicating, so we're gonna pass this dividing, and then we're gonna get the square root, and it will give us 0.49 seconds. And this is how we get the time. And now we gotta just get the distance with the formula with this one. And since we know the time and the distance, it's pretty easy. I mean the velocity. We just multiply this and we'll get 9.8 meters. And that's it. Okay, so we're almost done. We're just gonna go to the example of a uniform circular movement. I'm trying my best. Okay, so a bicycle wheel has a 33 centimeters radius and it spins of 40 revolutions per minute. What's the linear distance, which linear distance is equal to s, did the bicycle travel in 30 seconds? So the revolutions per minute, the 40 revolutions per minute, we're gonna pass it to revolutions per seconds. And to know that, you can check the link in the description. I'm gonna show you how to do those changes. And it will give us 0.666 revolutions per second. And that will be the frequency. And to get the velocity, we're gonna use this formula. So it will be 2p times the number of the devil will be equal to 4.18 radius per second. And we're gonna get the angle with this formula. So we have the linear velocity, the linear velocity and the time. So the time you're gonna pass it multiplicating to this side, and it will give us 125.4 radius. That's gonna be the angle. And now, the radius, you have to pass it to meters, so it's a little bit easier you to do it. So we already have the angle and the radius. So again, the radius is gonna pass multiplicating to this side, to the angle, and it will give us 41.38 meters.